Okay, so for our CPE 301 final project, me, Dayton Flores, and Joseph Sharp Halbin, we did a multiple lux sensor controlled by a microcontroller.
The aim and accomplishments for this project were to create a circuit that can use multiple lux sensors to measure differing lux values, which can then be transmitted through RF and displayed through USART. So what we pretty much do is we would get the lux value, we put it in the RF code, we send it, we receive it in the other RF, and then we print it. The accomplishments was to successful implementation of the TSL, so the lux sensor. The TCA 9548A was the multiplexer, which selected between the three lux sensors, and the NRF chip, which was just for the RF frequency stuff.
So these are our schematics. We basically had two circuits. So this is going to be the receive circuit. Here's the Atmega 328, the microcontroller we have. We have the FTDI basic programmer, which connects to the USB. And then we have the NRF chip, which is the radio. This is going to receive data from the transmit. And then we have the power source. And then this is going to be our transmit circuit, a little more complex. We have our Atmega 328, the microcontroller here, the same FTDI USB programmer, another NRF chip that transmits the data, the raw data, and then on this side we have the multiplexer here, and then connected to the multiplexer will be three lux sensors, which we select through the microcontroller.
So the components we used were two Atmega 328P Explain Minis. So we didn't have to use the FTDI chip in the same way. Three of the lux sensors, the TSL 2591 chips, the multiplexer chips with the TCA 9548A chip, two of the NRF 24L01 chips to communicate between the two microcontrollers. Interfaces, so TSL 2591, it was using I2C to communicate, the Atmega 328P was using I2C to communicate with the lux chip, and the lux chip's address was 0x29, and they have the same address, so you have to interface with them with a multiplexer. The NRF chip was communicated with the Atmega with the SPI communication, and the FTDI using USART, but the FTDI is a part of the Explain Mini. And then how we got the values to print via USART was with the data visualizer in Atmos Studio 7.
So this is the way we developed. This is going to be our transmit code, and so we used a couple of libraries that were resourced to us. We used G4LVANIX's GitHub for the I2C libraries, which were given to us. For the NRF libraries, we used Antoine Leclerc's GitHub, which was also given to us in class. And then the USART and TSL functions were given in various lecture notes. And it's going to be the flow chart. First we initialized USART, then we initialized I2C, then we initialized the lux sensor, then we initialized the NRF chip, and then we started our main code.
So for data collection, the TSL 2591 chip was communicated with the Atmega 328P Explain Mini via I2C. So raw I2C raw lux values were given to the Atmega, and the Atmega will convert the lux values and then graph the implementation. So it'll select the chip using the multiplexer, to select it, get the raw data from the lux chip, convert the raw lux value to something that makes sense, and then send it to the data visualizer for printing.
And then the way we actually printed those lux values, we used the D2STRF function to convert it from a float to a string, a char buffer, and then we called our UART display string, and then which consequently called the UR print character, and we kept printing character by character until it was null, and then after it was printed, then it would go back and get lux values again.
So these are demos these are the demo videos for our code. So it pretty much shows the values that are outputted through USART. Yeah.
So these are our contributions to the project. As you can see, we pretty much went 50-50 on everything. I mean, he did a little bit more coding, I did a little bit more implementation. We split everything basically 50-50. And then that's going to be his half of the work as well.
And that's it.
That's all.